Continuing with classification algorithm, we'll now go to what is called as the KNN algorithm. Now there are two different algorithms that we have over here. One is KNN and the other is K nearest neighbor, right? K means clustering. KNN is K nearest neighbor, and then you have K means clustering. So these are the two different algorithms. Kindly do not confuse them. Yes, they sound similar, and to an extent the approach is also similar, but then when you say KNN, it is classifying for one particular object, and when you say K means clustering, then it is dividing the data into groups, into clusters. So the purpose of both the algorithms, yes, even though they are classification algorithms, but the way they are used or the purpose of using them, they are totally different. Okay. Now, again, what we'll be doing is we first get started with the concept. We'll understand the concept first, and then obviously we'll try and demonstrate this with the help of an example or with the help of a program which works on a certain data. Now, what exactly what exactly is the purpose of KNN algorithm? Yes, please understand this. Also, the concept that you study over here is going to be very helpful in understanding K means clustering as well. Okay, going further. Now, what do you mean by KNN? K nearest neighbor. You'll understand the why the name K nearest neighbors as we go ahead with the algorithm. But then understand this is also called as the lazy learning algorithm. Now what happens is this is actually a supervised learning technique, so it will be reliant on the data that is given to it. But at the same time, this algorithm will not have any provision, or this algorithm does not have a provision wherein it can keep learning or it can keep upgrading using the data that is available to it. So that is, you can say, one little limitation of this algorithm. That is why it is called as a lazy learning algorithm, right? Also, what it does is it is also called as a non-parametric learning algorithm, because what it will do is it will go and use the data from the data set, but it cannot correlate or it cannot find, say, some specific relationship or something, or it does not even try to identify any relationship or something pertaining to data that is being used or the underlying data. It will get you the results, no doubts about it, but then it will not try to get into the correlation part of the data. But then whenever you say that the algorithm is a lazy learning algorithm, this is something which would be applicable to it. Lazy learning algorithms. Okay, now let us understand the concept first. I'll come back to this later. We'll first understand this in simplest possible terms. What is the idea behind KNN, or how do we go about working with this algorithm? What's the whole idea behind KNN? Now, guys, you have some pictures on your screen. Can you just tell me what is it that you can see on your screen? What are the groups that you see on your screen? Can you quickly put it in the chat window? Yes, some fruits and vegetables. Yes, what we see on the left hand side of our screen, they are all vegetables, and when we see something on the right side of our screen, they are all fruits. True. So this is all fruits and vegetables. That is what we have. Now over here you can say we now have two groups here. One is fruits and the other is vegetable. See guys, when we classify something as a fruit, this is because it has certain attributes, it has certain features which are it has certain features which when satisfied it will be classified as a fruit, or there are certain features which when classified it will be which when satisfied it will be classified as a vegetable. So anything that needs to be classified, we'll always compare it with the features of the group, and wherever it matches accordingly we'll classify. Now suppose I get this, I've got another object, I don't know what this object is, I want to classify it, I want to group it. You've told me that there are two groups over here, vegetables and fruits, and now there is this new object which I need to classify. Please tell me, where would you put this particular object? What is this new object that you see on screen now? Yes, it's a pair. And where do you classify it? You'll classify it as fruits. Now guys, just observe this. When we are classifying something, basically what happens is we all know what fruits are. Now when we say we know what fruits are, so basically we know what are the features of a fruit, or what are the things that are required to be classified, or sorry, what are the things that are required to be true for something to be a fruit. But guys, observe this. When I compare this, okay, it has certain features matching with this. No, there aren't too many features that match with this. Yes, there are features matching with this, right? Maybe there are features matching with this. Now, when I compare this, now even jackfruit is a fruit, but it does not match over here. Right. So jackfruit, yes, even though it's a fruit, if I talk in terms of the shape or whatever, then it is very different from a pear. So if I try to get a direct match between a pear and a jackfruit, obviously that may not always happen. But what I find is over here that a fruit now, for pear to be classified as a fruit, it's not necessary that it has to match with each and every fruit that is known to you. But if it matches with most number of fruits, I will be happy to classify it as a fruit. Doesn't matter if it did not match with jackfruit, but if it matches with these things, I will be able to classify it as a fruit. Now had I got an object which had matched with lot of say had it matched with a lot of vegetables, then we would have said that this is a vegetable. So this is how we have classified it, because it matches with most of the fruits around. That is why it's a fruit, right? So that is what it is, right? So oh, no, Mayura, it'll maybe see if it matches maybe a little bit with a potato, but then it's about the numbers. If it matches here, if it does not match over here, if it does not match over here, for most of the objects, if it does not match, then I'll say that it is not a vegetable. Now, if it matches with most of the vegetables, then I'll say that it is a vegetable. Now, guys, just tell me something. Suppose in this figure, suppose I have a tomato. Please tell me, how do you classify this? Vegetable, okay. Guys, can you all just quickly Google whether a tomato is a fruit or a vegetable? This guys shouldn't take more than 10 seconds to Google that. Right. So what you'll find is that most of us think that tomato is a vegetable, but actually it's a fruit. Actually, what happens over here is the properties will match more to that of fruits. That is why it's a fruit. But we, while cooking, use it mostly like a vegetable. So most people are under the impression that tomato is a vegetable, whereas tomato is actually a fruit. So point over here is that whenever my algorithm will also work, it'll just try to compare the parameters, and wherever the parameters match the most with a particular group, we'll say that it belongs to that particular group. Okay. Now, so this is what is the basic idea behind, say, KNN algorithm. Now, guys, what we'll do is we'll understand the same thing in a slightly more conventional manner. Now, observe what is this. Now, over here, I have some points, say some red points and say some yellow points. Now, based on this particular data, I want to classify this. I want to classify this particular data. We had seen something similar to this in support vector. The concept over here is going to be slightly different, but again, my idea is to classify something. So suppose if I say yellow dot say as fruits and say red dot say as vegetable, and then if I want to classify, how do we do that? Now, suppose I have this blue point, and I want this blue point to be classified as either say belonging to the red group or either say belonging to the yellow group. Now, when we spoke about support vectors, if you remember, we were drawing something like this, what was called as a hyperplane, and then we had something called as range, and then we had something called as support vectors, and based on that, we were classifying it. Now, what this algorithm is going to do is, over here, I need to decide a value of k. Right now, what is this k, guys? K nearest neighbor. So k is the number of nearest neighbors that I'm going to check before I classify this particular object. So k is the number of nearest neighbors that you would want to test or you would want to compare with before you decide whether this point belongs to the red point or the the red group or the yellow group. Now, what I'll do is, suppose we've decided the value of k as 3. That means I'm required to check the distance of this particular point from the 3 nearest neighbors. So suppose if k is 3, in that case, what I find is, if I'm checking for 3 neighbors, out of which what I find is the 2 of the nearest neighbors are yellow group and 1 is from the red group. So 2 are from yellow group and 1 is from red group. So what I know is that this particular point actually is more closer or is closer to more of yellow points. So I know that this belongs to the yellow group. So that is what we'll do. So if I go with KS3, this point will be classified as a member of the yellow group. But now, say this was the initial diagram. Now, suppose if I decide the value of k as 5. Now, that what this means is that I'm going to compare or I'm going to check the distance of this particular point from the 5 nearest neighbors, which are the 5 nearest neighbors. Now, when I take the value of k as 5, so suppose, oh, sorry, this is 6. Suppose if I take the value of k as 6, what I find is of the 6 nearest neighbors, 4 are from red group and 2 are from yellow group. So what I know is that this point that I've decided, or this point that I'm planning to classify, this point this point is actually closer to the red group, so this is classified as red. Guys, I haven't changed the points, I haven't modified or I haven't moved the points at all. The only thing that has changed is the value of k, and you will see that if I change the value of k, it might just happen that the entire solution or the entire answer will change over here. So guys, what is most important is how you choose the value of k, how efficient your value of k is, or how accurate your value of k is. That will clearly determine the overall efficiency of this particular algorithm. How you choose the value of k is what is very, very, very important for us, right? Okay, so that is how this algorithm is going to work. But now the question that needs to be asked is, how do I select the value of k? Because what we just saw is, if something goes wrong with the value of k, or if we don't select it properly or efficiently, my entire answer would change. When I went with k as 3, the point was classified as yellow. When I went with k as 5, the point has been classified as red. So the total solution changes. The result of the algorithm changes altogether based on the value of k. So k is the most important factor that we work with. Now, first and foremost, there is no fixed formula. I cannot tell you, okay, you do this, or this is how you go and calculate the value of k. No, there is no fixed formula. Just that, don't use the value of k to be very small, or at the same time, don't take it to be too big. So that is some intermediate value is what you need to look at, right? So what we need to do is, before we actually start applying this algorithm, we need to have a look at that particular data and then try and understand and then try and decide what are the best possible values of k. So that is what we need to understand. Okay. Now, I told you that over here, I'm required to calculate the distance of any point to be classified from the nearest neighbors. See, guys, please remember, it does not always happen that the points would be in straight line that you can get just this particular distance. Now, over here, suppose if I want to get the distance of this yellow or this blue point from so many different points around, how do I calculate it? Now there are two ways in which you can calculate the distances. There's something called as Euclidean distance, and then there is something called as Manhattan distance. In fact, Python provides a library called a method called Minkowski, which gives you the provision of using both. So even while implementing, even though there are two methods, there is just one, there's one concept called Minkowski, which we'll see at some stage. So using that, you can use either of them. Now, guys, understand what are the distances. By default, we always use Euclidean distance, but if needed, you can always use Manhattan distance as well. Now, how do you calculate the distances? Now, suppose these are the 2 points that I have on this graph. Now, what I need to do is I need to find out the distance between 2 points. We'll be talking about the Euclidean distance first, and then we'll be talking about the Manhattan distance. Now, observe this. Now, look at the Euclidean distance. Euclidean distance is the straight line distance. So this is the x coordinates are 6 and 1. So this is 6 minus 1 the whole square plus 1 minus 5 the whole square. So I get a Euclidean distance over here. Now, if I want to use Manhattan distance, so Manhattan distance is always measured along the right angle. So this is the distance that I'll calculate using Manhattan distance. So this is 6 minus 1, magnitude of 6 minus 1 plus 1 minus 5. So I get this particular value. So this is how we'll calculate the Euclidean distance and the Manhattan distance. Guys, needless to say, again, when we go to the implementation part, all this will happen automatically. You have predefined functions which will calculate the distances for you. You will have functions which will do everything for you. Just that you should have an idea of what's happening in the background. That is why we keep discussing all these concepts. Okay, guys, any doubts with whatever we've discussed so far? See, whenever we talk of distances in ML now, we'll always talk in terms of Euclidean distances or Manhattan distances. And amongst these two also, the Euclidean distance is the one. Euclidean distance is the one which is used most of the time. So that is what it is, Euclidean distances. Okay. Now, what we'll do is we'll first try and understand this with a little example, and then I'll go and demonstrate the same thing with the help of a program. Also, guys, again, you will see a lot of calculations happening over here. You will see a lot of mathematics over here. But again, the best part is when we go to the implementation, what you will find is that there is say a ready-made function which will do everything for you. Now let's take up an example. Let's see what is this. Now suppose I have this particular data with me. Now what is this data? Please understand this. Suppose the data that I have is, I have some information, say about say how many, 18 values over here. I have some information about few people. Suppose the height of that person who bought this t-shirt was 158. The weight was 58 kg. The t-shirt that the person bought was say of size small. Then this height, this weight, this is the size of the t-shirt that was fitting that person. Similarly, there were people for whom the size was L. There were people for whom the size was S. So suppose I have this particular information with me. This is the data set that I have with me. And what I now need to do is, suppose there is a person who comes in who says, my height is 161 and my weight is 62. Now, based on this particular data, I need to classify this particular candidate as a potential candidate who would be able to wear, say, S size t-shirt or an L size t-shirt. Or you can say, I now have to make a prediction for this person, whether this person will be able to fit into an S size t-shirt or an L size t-shirt. Now, what do I do over here? Please observe this. See, look at it like this. What I'm required to do is, you have to start thinking of these as coordinates like this. See, look at this. When I was calculating the distances, this was 0.15 and this was 0.61. in simple terms, what I can say is that this is x1 y1 and this is x2 y2. And what did we do? 6 minus 1. So this is x1 minus x2 the whole square, like this, plus y1 minus y2 the whole square. So square root of this is what we are calculating as your Euclidean distances. Now over here, guys, please understand this. Now I'll look at it like this. Height and weight of this person is 158 and 58. This is my, say, x1 y1, and this is the, what was the weight, 161 and 62. This is x2 y2, and that is what we are now calculating, right? Okay, so now just observe this. 161 minus 158, right, is 3. 3 square is 9, and 62 minus 58 is 4. 4 square is 16. So square root of 9 plus 16, which is 25, square root of 25 is 5. So basically I'm calculating with reference to the height and weight given over here, right? Now, so that I've got over here. Then we've calculated this, right? 161 minus 158, the whole square, plus how much was it, this one, 62 minus 59, whatever is the value, say 3 whole square, and then the square root of that. So I'll get this value. So what I've done is basically I'll calculate the Euclidean distance of this point. See, this is the point, or this is the data for which I'm trying to get the result. Now over here I've tried to get the distances, the Euclidean distances of this point from all the points. Now, once I get these distances, what I'm going to do is, suppose I'm using the value of k as 5. I'm using the value of k as 5. That means I'm trying to get the 5 nearest neighbors to this particular point. Now observe this. Over here we've got so many different values. What I'll do is, for me, say suppose the height is given as 161, I'll check which are the values, which are the nearest 5 values to this particular nearest 5 values to this value 161. So what I find is, say, 160, 160, 163, 163, 163. Suppose these are the 5 nearest points that I have. What I find is, of the 5 points that I'm getting, which are the nearest to this point, 4 of them fall into this group called small, and 1 of them falls into this group called L. So what this indicates is that most people having a similar height and weight to this person that I'm talking about could actually fit into the small size t-shirt, and maybe there was an odd case where the person needed an L size t-shirt. So what do? We'll say that this person will be able to fit into a small size t-shirt. Guys, also please understand this. When you talk of classification algorithm, when you talk of say prediction algorithms, obviously we'll try our best to make them as accurate as possible, but that does not mean that they will be 100% accurate. There might be an odd case where someone should have been ideally advise a small size t-shirt, we might end up advising large, or say vice versa. So that is how it works. So precisely this is how your KNN algorithm is going to work. Key is, what is the value of k that you decide. The moment you decide the value of k, what you'll do is you'll calculate all these Euclidean distances. Once you get all these Euclidean distances, you can just calculate the values for, say, the nearest neighbors, and once you get the values, based on that you can always go out and classify whether the person needs a small size t-shirt or whether the person needs a large size t-shirt. So that is how this is going to work. Is this fine? Guys, any doubts with this? Because this is what the concept is. We will now be looking at the demonstration part of it.
Sir,
Yeah, please go on.
sir, just a general query. Here you have taken from cell number, like row number 5 to row number 9 as the nearest neighbors. But what if
Yes.
we calculate the distance for other rows also, and we can even see that on the 10th row the distance is 2.8, while on the 5th row it's 3.1. So why have we taken that as consideration and why not the 10th row?
See, understand this. I'm not even looking at these values. No, I'm not even looking at these values. I've calculated this, right? I need to look at, see, my height is 161. So over here, we've calculated this, and we'll see over here, see, I've taken 158 also, and I've taken 163 also. So most of the grouping that I have is this. Now over here, what we'll do is we will precisely look at some little combination, this value and this value. What I find is that the least values or the distances are these. So these are actually the nearest points. So we will just look into this. These are the nearest points, but because my k value was 5, either this will get added or either this will get added. So based on these values, we've selected the 5 nearest points, and from there we are getting this value. See, if you say I don't want to start with, say, this row, I want to start one row lower and accommodate this, even that is possible. Even that is okay.
Uh, so, but assuming that
Uh-huh.
for the later distances we get distance around 2 and 1.5, then in that case our answer would again change if we consider k
No, but
nearest.
what happens is if the person, if suppose say you get a distance say 2.1 over here, one, that won't happen, because what is happening is the values are calculated with these and these, na. So if you say that these values are changing, if the difference is changing, then this distance is bound to increase. Obviously, it will increase. So that won't happen over here. That won't happen over here. See, if at all I go this way, says let me try and get it for this row. So this is square root of 161 minus 170 is 9. 9 square is 81. Plus this is 62 minus 63, which is 1. 1 square is 1. So this is square root of 82. Square root of 82 is something like 9 point something, na? So if these values increase, if these values change, these values are bound to go up. It won't happen that you'll get lesser values than this as you go ahead. So what's the point in doing it?
Okay, so I didn't consider the ascending order seam.
It will automatically happen, because
Okay.
if the difference keeps on increasing, if the difference between this value and this value keeps increasing, obviously the values will keep increasing. You will always find the least values in the group, which would be your answer. It's not possible. See, actually dekha jaye, so 158 and 58, these values are lesser, but because 161 and 158 and 62 and 58, the gap is more, this value will always be higher. So it won't happen that as you keep calculating more, you'll start getting better distances. That won't happen. So generally what we do is we'll get these values. Then what we'll do is we'll just look at the combination. 160 hai, apna 161 tha. So 160 and say these values accordingly, we'll compare and get whatever is needed. Okay.
Okay, sir.
Okay. See, Shantakumar, see row number 4, you asked row number 4, right? Which is, just a sec, I'll just erase everything. See, this is row number 4. What happened with row number 4? Or you're talking of this? See, it's not picked up like that. What we'll do is we'll pick up the values which are the closest. See, you can actually consider this. It's okay, but you cannot take this, because the least values that I'm getting are over here. So you can take this combination. This is fine. You will not take this particular combination. See, who's this? See, Sai, what happens is I'm not interested in the coordinates at all. Even if you're calculating your Manhattan distance is also calculated based on the coordinates itself. So if the points are further away, even the Manhattan distance would be higher. So whether these values are say 2.2 or whether these values are say 4.4, if this value has increased, all the other values when I'm using Manhattan distance will also increase accordingly. You'll still find that even with Manhattan distance, you'll find the minimum distances over here itself, right? So that is how it works. But what you cannot do is that, okay, for calculating these distances I'll use say Euclidean distance, for calculating these distances I'll use Manhattan distance, then to everything will go for a toss. No, you will use either Euclidean everywhere or you will use either Manhattan everywhere. You cannot use a combination, or you cannot say thoda Euclidean or thoda Manhattan use karenge. No, it cannot work like that, right? So that is how it's going to be. We'll be again coming back to this in a lot of detail when we go to the k-means clustering algorithm, because clustering will make things even more slightly more difficult. So that is where again we'll be revisiting this whole idea of Euclidean and Manhattan distances. But then this is a pretty simple, straightforward algorithm that we have. Okay. Now, what we'll do is we will try and understand this concept with the help of this data set called social network ads, right? There's a CSV file, the comma separated value files that I'm going to use for demonstrating this particular concept. Now, I'll show you the data set first. This is social network. Guys, all these data sets are available on the website or the app, and in the Python download section. Okay, now guys, what do we have in this particular data set? We have some information. We have some information that about some buyers, right, on social network. So we have about 400 records over here. We have information like gender of the person, age of the person, and the estimated salary. And we are trying to look at a particular product. So over here, I'm just trying to understand whether this person is a potential candidate for purchasing a particular product, or the person is not a potential candidate. Now, I could make my decision based on gender. I could make my decision based on age, gender and age combination, age and estimated salary combination, and so on. Now, if you see in purchase column, there are two values, zeros and ones. Zeros is when the person has not purchased that particular data, and one is when the person has purchased that particular commodity that we are talking about. So what I want is, based on whatever the combinations that you want to use, now it's for you to pick and choose what are the combinations. Suppose gender and age combination is what we look at. Like, see, suppose when I am posting my ads on social media, say the kind of ads that you saw, right? So for me, it doesn't make a difference as far as the gender is concerned. Maybe men as well as women both would be interested in maybe studying, say, machine learning. For me, what matters is the age factor, because people who are professionals or people who are students, what is the age group? Generally that age group would be anything between, say, 19 years, 18 years, and say about 50 years. So that is generally the age group of the people who would be willing to learn. Now, that does not mean that someone who's 15 years old is not willing to learn or doesn't want to learn, or maybe that does not mean that anyone who's over 50 years would not want to learn. Obviously, there are people who keep learning all the time. There are people who start very young. But for me, if I look at the people who are enrolling for the courses, out of 10 people, 8 would be in the age group of, say, between 18 and 50. So I would be interested in targeting that particular audience. So over here there are different parameters. So, acha, even when you're publishing your ads on social media, it even gives you an option that, do you want to target only the people who own iPhone, or maybe do you want to target the people who actually use an XYZ gadget, or who have a tablet, and so on. Now, even that information is available. Now, why is that available? Suppose if I'm trying to sell, which is something which is very expensive, or which is, say, exclusive to, say an Apple product, obviously there's no point in going to, say, if it is something exclusive to, say, Apple product, then there's no point going to, say, people who are not using any Apple products at all. That would be a waste of ad for me, a waste of money for me. So I can actually get all that information. So depending on what you want to do, accordingly you need to decide the factors, right? This is called as feature engineering. We'll be talking about it a little later today. But guys, please understand this. Over here, it is extremely important that you pick and choose the attributes that you want. So over here, maybe looking at, say, the combination of gender and age, or age and estimated salary, or gender and estimated salary, whatever you want to categorize, you want to try and classify whether a potential candidate will go ahead and purchase the product or not. So that is what maybe we want to try and understand. Now, what exactly is this particular program? Now, guys, please observe this. See, actually speaking, there is not too much of code, but there are certain extra things that I've done in this particular program. So hopefully you should be able to see lot of stuff as well. But practically when we are designing, see guys, this applies to almost all the codes that I've given you. My codes, I've done a lot of additional things so that you can see what's happening. But practically when I'm designing the models, no user is interested in whatever we show them these additional things. If we can just give them whatever are the results, they are more than happy to work with that. So that is what is required. So even in this program, there'll be a lot of additional things that we have. Okay. Now the first thing that I've done is, as always, I've started by importing pandas, numpy, and matplotlib. Now I'm opening this particular data set, pd dot see guys, right from day one, I've insisted that the Python course which you provided, please go through the data visualization part, because you will come across all these things there. Unless you've gone through that, you might not understand these codes, huh? Please. So over here, what I'm doing is, using this pandas object, I'm opening that particular data set, and this goes to this data frame called data. Now when I print data.head, it will print the first 5 rows, just telling me whether the file has opened properly or not. So now when I run this, observe this. This is what I see over here: user ID, gender, age, estimated salary, and purchase. Right now, this is what I'm getting over here. Okay, now I'm going to extract out some particular data from this data set. ILOC is actually a function in Python which will help you extract the data from your data sets. It could be from a database, it could be from an Excel sheet, it could be from a CSV file, it could be from a TSV file, either ways. Right now, observe this. Data is now the data frame which contains all 400 values. I've displayed just 5, but there are 400 values over here. When I say data.iloc, what it will do is, it will go to your column numbers 2 and 3. So column number 2 is gender and age, and okay, I'll display this also for you. Just a sec. See, if I write here, this is what print X. See this, please. See. So sorry, age and estimated salary. So over here we are going with these two parameters, that we need to look at the age and estimated salary and accordingly classify the person, whether the person is a potential candidate or would be interested in buying that product or not. So X is basically the parameters on which I need to make my decision. See, going back to this particular graph, please observe this, what we just discussed. See, I have these red points and I have this yellow point. So I have two groups, and based on that, I'm going to classify over here. Now, what I'm trying to do in that particular example is, I will take, say, age, and I'll take the estimated salary, and I'll plot those points. And then later on, when you give me the data, I'll plot that point somewhere over here. And then depending on the values of value of K and the distances that I get, I'll tell you whether that person would be interested in buying the product or not. So that is what is the aim out here. So over here, what we've done is, we've got these two parameters. Now the third parameter that we have is this one, ILOC 4. Now 4 is this particular column called purchase. Never forget that when you talk of numbering of rows and columns, it always starts at 0. Right? So 0 is age, 1 is gender, 2 is age, 3 is estimated salary, and 4 is purchase. So I can display Y also over here. You will see that purchase column. So that is what we've got over here. Now, for designing this particular model, I'm required to divide this data into the testing and training model. Now, we've discussed this in both the sessions earlier, that whatever data that you get, you need to divide it into the 70-30 ratio. 70% is the training data and 30% is the testing data. And how do we do that? Using the train test split module from scikit-learn. So this is something again which we've seen in so many algorithms that we've discussed so far. So from scikit-learn, what I'm doing is, I'll go to train test split. What this does is, it divides your data in 4 parts: X train, Y train, X test, Y test. So 30% of the X values in training, 30% of the y values in training. Sorry, 70% of the x values in training, 70% of the y values in training, and 30% values in x for testing, and 30% values in y for testing. So that is what we get over here. Now this is where we change the value. So that is 0.3. If you change this to 0.2, it becomes 80-20 or whatever you feel like, but 70-30 is generally the standard one. Now over here I'm using something called a standard scalar. Now, what happens is this is not always required, but observe this, guys. A lot of times, what happens is whenever we are working with a value, there can be a huge difference in the values that we have. Now, we are trying to use both these parameters, age and estimated salary. So I'm required to get a graph which is age against estimated salary. That is how I'm going to plot. Now, guys, age me, what would be the difference, or what we spoke about the range in one of the sessions earlier. If you talk of the range, what would be the different age groups? See, minimum, suppose say I see 19 over here, and I say, see, I think maximum, what is it, 42? I can say 42 over here, 49, 57. Okay, I think 57 is the highest value that I see in age. So the range is, I have minimum value of age as 19 and maximum value is say 57, right? But if you look at the estimated salary, I can see 19,000 to start with, and then the values keep increasing. I can also see 1,50,000, and then I can see 1,35,000. So the values are pretty high. Now, what happens is practically when I'm planning to, sorry, what happens is practically when I'm planning to get these graphs, if the range on over here is very less and the values are very high, and if I'm plotting a lot of points, so a lot of clustering happens. All these points will come like this if they work like this. So what we need to do is we need to just standardize this so that this gets spread out properly, and then this also gets spread out properly, so that the graph can become proper. See, guys, understand this. Suppose if my data is okay, but because of this grouping they are so close, it would cause a lot of problems to the algorithm working. So what we generally do is, if we say that the range is very different on the x-axis and the y-axis, and see, this is something which is not specific to say this algorithm. This will apply to any algorithm that we work with. So over here what we do is we will take the data and we will try to standardize things. So over here I've created an object sc_x for standard scalar. So what I plan to do is I just plan to get the values on the x-axis a little more spread out. So that is what we are trying to do over here. See, finally, where is it? See, I'm going to plot age against the estimated salary. So that is what we need to do. So I need, don't bother about that graph as of now. So that is what I need to do. So that is why I am planning to standardize this. I haven't done that as yet. As of now, I've just created an object of this class standard scalar, which again is from the scikit-learn, the scikit-learn module or the library that we have. As always, our favorite fit function, which will do everything for you, xtrain, scx. Now scx is an object of standard scalar. I will pass the training data for x over here, and I'll pass the training data for x test over here. So basically xtrain and x test are now the new set of values which have been standardized by this standard scalar. Now this is where my actual KNN starts. You will see like most of the algorithms, literally 4 lines are what we are going to do. And what are the usual functions that we work with? There is a fit function, there is a predict function, then there is an accuracy function, same 2-3 functions, right? Observe this. What I'm doing is from scikit-learn, I've imported kneighbors classifier. So that is what we've got. I'm creating an object of this class called kneighbors classifier. Now over here, n neighbors, the value that I've decided is 5. The metric is Minkowski. Now Minkowski is that particular metric which gives you a combination of both Euclidean as well as Manhattan. If you see later on, I've written p is equal to 2. So if I go with p as 1, it uses Manhattan, if I go with P is equal to 2, it goes with Euclidean. So you don't actually need two separate modules for checking with say Euclidean or for checking with Manhattan. You can just use Minkowski, and Minkowski will give you both the provisions. But guys, whenever you're working with multiple data, please don't do this, that you are say half the data you are using say um, Manhattan, and half the data for half the data you're using Euclidean. That will mess up everything. So that is something which you should never do. Now, all that mathematics that we spoke about, everything as always is going to happen in one line. Classifier is an object of class k neighbors dot fit function. As always, our fit function which does everything for us, x train comma y train. You've passed the x data and the y data to this classifier function or this fit function. Guys, literally these one lines are what we've done for linear regression, for logistic regression, for support vector machine. See, you need to be smart when it comes to handling machine learning. If you see, the same thing keeps getting repeated over and over and over again. All I've done throughout, when I was required to implement linear regression, I created an object of linear regression, say x, and then I've written x dot fit. When I wanted to implement logistic regression, I imported logistic regression, created an object x, and then x dot fit. So you have a predefined class available for every model that you want to decide. All you have to do is create an object and pass that function. See, even if you have no idea about how KNN works or the mathematics behind it, it doesn't matter, because this function will do everything for you. You are not required to do anything. Now, similarly, I want to carry out the predictions. Classifier dot predict. I'm passing the testing data and I'm getting the predicted values of y. How do I compare the predicted values? By using this classifier score. Over here, I'll pass the x test data and y test data, and then it'll give me the predicted accuracy. Because actually speaking now, for this algorithm, I could have stopped right here. This is more than enough as far as the model design is concerned. What we'll be discussing further is just for us to identify or for us to understand what's happening here. See over here, this model that we have designed, the accuracy is 0.9. So almost 90% accuracy is what I can get for this particular model. Okay, but now, to make things obvious for you, we will see what is or how to create a confusion matrix. Now, confusion matrix is also something, any model that you're designing, once you finish designing the model, you can create a confusion matrix if you feel like. Now observe this, this from scikit-learn.metrics. What are metrics? Metrics are precisely those parameters or those tools which help us in checking whether this particular module is good or not, or how accurate this particular model is. What do you pass to this confusion matrix? To this confusion matrix, you're passing the test data for y and the predicted data for y. It will compare how many of them match and how many mismatches are there, and then it will print the confusion matrix. So now, if I just go till the confusion matrix, what do I see over here? See this, please. Now, this is the confusion matrix: 72, 7, and 4 and 37. What this means is, say, what was suppose mm, 72, 7, 4, and 37. Okay. We got 72, 7, and 4 and 37, right? So I'll put it as, say, 1, or I'll put it as positive, and this is 0. I'll put it as negative. I'll put it as 1, which is positive. I'll put it as 0, which is negative. Right. Now, what is this? So of the data that we have, if you see over here, say what we are talking about here is that of the instances that we had, wherever it was supposed to be positive, so this is the actual and this is the predicted, what my model is predicting. So 72 times it happened that what was supposed to be positive was predicted as positive. But yes, 7 times it happens that it was supposed to be positive, but it was predicted as negative. So this is an error. Similarly, 37 times it happened that whatever was supposed to be negative was predicted as negative. But yes, 4 times it happened that what was supposed to be negative was reported as positive. So this is an error. So confusion matrix gives you how many times your module is working fine. Yes, there would be some accuracies, there would be some errors while trying to predict, say, the positive values. There might be some errors while trying to predict the negative values. So that is how this is going to work, right? So this is how we will be working using a confusion matrix. So confusion matrix is basically just an indicator of how good your model is or how accurate your model is. It has got nothing to do with KNN. Any particular algorithm that you're designing, once you finish designing, you can just go ahead and print a confusion matrix for it. So it's like that, and it's very simple. See these 3 lines now, again, if you see these lines also, they're not at all specific to this particular program. If you see, what have I done? I've just passed the no, not classifier, sorry. If you see, for the confusion matrix, all I need to pass is the y test and the predicted values of y. So we have used the same variables everywhere. So these 3 lines, any model, you just fit these 3 lines in the end, it will display the confusion matrix for you. Now beyond this, whatever you see is actually additional. Now over here, this is just going to give you a listed color map. I'll just run this program first. It takes a little bit of time for it to plot it. It's called as a mesh grid. Because for all the points, it'll keep calculating the distances and then it'll keep plotting. Okay. Okay, it'll get printed. We'll just go ahead in the meantime. So what I've done is I've created a listed color map. See this. Now over here, what has this done is it has first analyzed the entire data, and wherever you find, say, values, wherever they found that the age and the estimated salary combination they would not buy, they have plotted that all that in as red dots. And then wherever people have using the estimated salary and the age combination, wherever people have bought, we put that in the green dot, so it gives you a little idea. Now if you see, in the green area there are some red dots. That means it is still possible that there are some people who satisfy the estimated age and the age and the estimated salary criteria, but they'll still not buy the product. So that is why you're seeing those red dots in the green area. Similarly, in the red area, you are finding some green dots over here, right? So when you get these green dots over here, when you get these green dots over here, so what this means is that there are some people who will satisfy the age and the estimated criteria, but they'll still buy that particular product. Now if you see this output carefully, there is a grid behind, right? So that is what is called as mesh grid. And then based on that, upon that particular mesh grid, I've put what is called as a listed color map. So there are two maps which are overlapping each other. There's a grid, and second is, on that particular grid we put a color map. So now just observe this. How are we going to do? Again, absolutely nothing specific to this program. Wherever you are, wherever you have any classification algorithm, you can just put this data as it is, this code as it is, and it will work fine for you. Now I'm creating a listed color map. What am I passing it? I'm passing the x set and y set as the test data for x and y, right? So I'm passing the test data, and then this is something which is going to plot the grid for you. So what it does is that the grid that you see in the background, this is how it is going to look at the values and create the grid for you. Now what I'm going to do is I'm going to create the contour. Now observe this using the listed color map. So plot dot contour, I'm just plotting this. Is this fine? Now observe this. Just a sec. किधर गया contour? So C map. Okay. Think all good now. Okay. Now, so what it has done is it has created that particular grid. Now what we are going to do is, now this is where we are plotting that particular contour, where we are passing the entire data like this. So you're not required to make any changes to this. It'll just accept the data. You can change the color if you feel like, and then it'll accordingly drop that contour. Now on that particular contour, actually there's a scatter plot. So what we've done is those points that you see are nothing but scatter plot. So what it does is for each value in the Y set, whatever is the data, it will create a scatter plot. And then on that particular grid, you have a scatter plot and you have a contour, and everything put together is the kind of graph that you will see. Everything put together will give you a graph like this. But guys, please understand this. This is again just for us to see practically. This is not required when you're actually designing the model. So if you stick to the same names, X train, X test, Y train, Y test, and say predict underscore Y, you are not required to change these codes at all. They will just go and create whatever is the data needed. So that is how you can design any model based on any two parameters that you have. So over here, we've gone with social network ads with columns say 2 and 3. Now, okay. No, straight away, I cannot go with that first column, which has say male and female, because the data is not categorical. I'll be first required to convert it from strings to categorical data. Say replace male with 0, say female with 1, and then it'll work fine. Because later on, I guess where we've used the data, it is working only with numbers. So this is how you'll be able to design what is called as the KNN algorithm. Is the concept of KNN understood? See, literally all of KNN has started from line number 27 and we finished at line number 37. Actually, these are the 5-7 lines which will cover all of KNN. Prior to that, whatever we've done is nothing but data collection, and what we've done now after that, whatever we've done, that is just for displaying the data properly. That's it. So that has got nothing to do with the KNN algorithm. Guys, is this concept understood, the funda behind KNN? Because later on when we do the classifier thing, then classifier thing, uh, that is where it might get a bit a little confusing, because it sounds similar but it is not exactly the same as what we just discussed. Kya hua? Sai, how to decide the values of K? When we go to the K means clustering, now that is where you will see there is an approach. What the system does is it doesn't work with say just one value of K directly. It will work with multiple values of K. It will create what is called as the elbow point, and that would be an indicator of how to use the value of K. I'll discuss that when we do K means clustering. Yes, we have to. You cannot just randomly use the value of K. Now in this program that I was demonstrating, I'd use the value of K as 3. You can use the sorry, we have used the value of K as 5. You can use K as 3 or whatever, but then the system would decide it using something called as an elbow point, which we'll discuss with K means clustering. See, when you're classifying the data, the classification, if you're going for say KNN algorithm, in that case, what you'll be required to do is you will be required to have only two parameters. You cannot go for more than two parameters, because I'm working in a 2D plane. I'm working on a graph, so I cannot help you with that. Now, if you have more than two things, then what you'll have to do is you'll have to go to something like k-means clustering. वो क्या करता है मालूम है? If there are four different things, so it'll create four different groups and then identify that whatever data you've given belongs to which particular group. So that is clustering. So that's again clustering that cannot be done with KNN. For KNN, you have to pick up two parameters. And whenever you're working with the data that is non-numeric and you want the data to be numeric, you saw what we did with logistic regression. What we did is we converted that particular data to categorical data, and then we can go ahead and implement whatever we feel like. What is line 28? Kya hai? See, this is where I'm creating an object of the k neighbors classifier. The value of k is 5. Metric is Minkowski. Minkowski gives me the option of both Manhattan and Euclidean. When I use p is equal to 2, it will use Euclidean. When I use p is equal to 1, it will use Manhattan. An object of KNN. Okay, done. Okay, guys, so that is what KNN is all about. What we'll do is we'll take a quick break, exactly 10 minutes, and then we'll start with another algorithm. Once that algorithm is done, again, we'll take a quick break, 10 minutes, and then we'll start with the third algorithm. So I think it is
Okay.
10:10 as of now. Exactly at 10:20, we'll start with the next algorithm. Yeah, please go on. Someone was asking something, please.
So I had a small doubt.
Yeah,
So all this is possible because majorly our data has been sorted and it's been arranged properly. So, but
true.
what if our data, like how do we clean our data exactly and how do we sort it out?
See, data wrangling, we discussed at lot of length with logistic regression wala question, the
So,
Titanic data. So
so
that
will it be applicable to all the other
Yes,
algorithms?
yes. See, data wrangling, basically, what do you mean by data wrangling? One, you just eliminate all the columns which have too much of missing data. Second, all those columns which are relevant and have little missing data, you replace that particular data with the mean of those values. And then what you do is you just pick and choose what are the attributes that you're working with. So that is what is generic to all the algorithms. It's not necessary that it has to be with, say, logistic regression only. Now every time if we start picking up data and keep on cleaning it and then keep on demonstrating these algorithms now, then it takes too much of time and the same things get repeated. That is why I kept insisting that logistic regression wala something that we did all of data wrangling. So you should always take the data, apply the data wrangling concepts, and then pick up whatever is the algorithm that you want. So this will come into picture only after data wrangling is done. You should never go with the data uh, which is bad. Now in my case, this is a pretty decent data. Now suppose if I was working on two columns, say age and estimated salary, and say 50% entries did not have salaries only, gone, my entire model is going to fail. So data cleaning has to be done, no doubts about it. Similarly, once this is done, even this last part, this remains exactly the same. So all you have to do is data wrangling, the steps remain the same. The last part, the things will remain the same. Beach mein, you just have to fit in whatever is the algorithm that you're planning to design. Now it could be linear regression, logistic regression, KNN, SVM, or whichever. Yes, data wrangling is needed everywhere.
So also
One
in
thing
the
that
list, yes,
mhm.
sir. So in the
Also what
list color,
happens is
uh,
practically when we create just a sec. See, practically when we are creating data today, we design those modules which create those data. So when you're pushing the data into your databases, we make sure that the data does not get corrupted, and it will take care of all these things. Because even if I'm implementing the data wrangling thing and say I want to design a model, if there are a million values, my data wrangling will take more time than actually designing the model. So I want the data to be as clean as possible. So as an organization, say, I don't know how many of you work as database managers or something over here. We always make sure that improper data never get pushed into our database, because every time it is not feasible for the system to implement data wrangling also. I saw that. Yeah, please go on. You're asking something.
uh, so in the listed color map, so in that, can you just explain the parameters like x1 comma x2? Then we have in numpy dot arrange. So these parameters like minimum and minimum maximum step are a bit unclear to me.
See, we understand these all these predefined codes which we get from Python for, say, any particular tool. One, we don't bother to get into the details, and second is we are not supposed to change them. Something like what happens with Android programming as well. Guys, understand, any tool, if it is required to work with the data, it will just take the data and convert it in the desired format. What these tools says, you just give us the data, we will arrange it in our requirement, and we will apply the concepts. So all I've done over here is I've just passed the data which I was required to work with to xset and yset. That's it. This is what I need to take care. I've decided what is the data in x test, I've decided what is the data in y test. Once I pass this, now this function called mesh grid from numpy, it needs the data to be arranged in a specific manner. So what it has done is it has set the limits. What is the minimum value that it wants on for the first row, what is the minimum value that it wants for the first column, and what is the step that it wants. So basically the step is giving you the thickness of the grid that you're working with. So if you want, you can just make some changes and try it, but then understand, moment you start making changes to it, it'll start giving you errors. So the key is you do not change this data. Now over here it is using function while plotting this contour also, it is taking this functions like reshape. Now whenever we use a function like reshape, this always converts the data to a format which goes between -1 and 1. So that is what it has done. alpha always talks about Alpha always talks about the transparency, and CMap always talks about what is the color combination or the color map that you want to use. So at most what you should do is you should change these colors. So guys, understand this. One, you're not required to get into all this, and second, when something is not going to change ever, what is the point in devoting time to that? Rather concentrate more on data wrangling and it will work fine. So